Yeah. You guys have any questions in your homework? If you have any issue with the grading, you can always write an email. So your exam is on Friday. So exam will be on Friday. So it will cover chapter 5, chapter 5, exam 2, same time. 11 to 12. 11 to 11 a.m. to 11 to 11. So it will cover chapter 5, 6, and 7. Chapters 5, 6, and 7. So the last one will be, which we'll be doing today, which is 7.6. 7.6. So 5.1 to 7.6. So we will look at 8.1 on Wednesday, and we'll do some review after doing the 8.1 review of Any question? You guys have any question with the quizzes? And the
They're gonna get another study guide, like a
yes.
frequent pre-exam study guide.
Have you graded quiz number 6?
What's that?
Did you grade quiz number 6?
Yeah. You did not get. I did. Did you add it? Quiz 6, I think it's your exam. It just says 0 in there. So yeah. Did you add it in exams?
I did not.
Did the yeah. The
You're talking about the
corrected exam, yeah.
Yeah, I did not.
I didn't do the corrections.
Oh, that.
I
Okay.
did not give it.
So you can give me your corrections, and then I'll go and check those. Maybe there is some issue there. So you're saying you can see that at the back. So we did not bring his quiz. The last one which we were doing in class. Okay. Oh, any question on your homeworks? So there was some question in some homework which someone asked. So when you're looking for when you're looking for let's say the one which we did in class, let's say 5 all over x minus 9 plus 4 all over x plus 9 equals to let's say 6. Let's say 6 all over x square minus 81. So if you're solving something like this, then after getting the values of x, let's say for this case, maybe 5 and 6. After you get the values of x, what you do, you take this one back to see whether this side is equal to this, okay? So you take all of them back here to see whether they are actually equal. So you need to proofread. So you need to check whether you're getting the correct thing, right? So before you write this one as a solution in your Newton, I think you need to prove whether it is giving you the correct answer. There is something like someone was telling me you get like negative something, and then when you put it in Newton, it's giving you the solution. I don't know whether you found something like that. I'm not sure. So you should get the correct solution once you take it back. Okay, now let's look at rational inequalities. And this is actually part of what we did previously. So now, how do we solve rational inequalities? How can we solve rational inequality? Are you seeing this? Rational inequality. Now, if we remember, if we have greater than, then this one was what? Oh, right. So if we have greater than, then this is basically or. And if it is or, then most of the time we usually connect it to the what? The union. So we connect it to that. If it is less than, then this one is what? And this one is actually and. So mostly if it is less than, we only have one, there is no connection. So it's only one, because it should be satisfying both the inequalities. Should be satisfying both the inequalities. So for this, it is either. So either. So either. And then this one is what? So it should satisfy both the inequalities. Both the inequalities. Okay, now, if we are given, let's look at example 1. If we are told to solve the rational inequality and write the solution in interval notation. Solve the inequality and write the solution in interval notation. We have our 4 all over x squared and minus 25 to be greater than 0. To be greater than 0. Then how should we solve this? How should we solve that? Now, to solve this inequality, then what you need to do is you equate this one to be equals to 0. The denominator to be equals to 0. So you write the denominator to be equals to 0. So you say x squared minus 25 equals to 0. Equals to 0. So once you write that one to be equals to 0, then since this is a perfect square, then therefore this is x minus 5, x plus what? It's equals to what? It's equals to 0. Yeah,
What happened to the 4?
what's that? What did you say?
What happened to the 4?
So what I say is, if you want to solve this, then we equate this one to be equals to 0. X squared minus 25 to be equals to 0. Okay. So once we set this one to be equals to 0, then we need to get, if we want to put them in the graph, then this will give us the intervals of the graph. Okay. So I'll show you how it happens here. So once we equate this one to 0, then using the zero product property, then our x equals to 5 and our x equals to what? Negative what? Negative 5. X equals to 5 and x equals to negative 5. Now, once we get those points there, then we now come here and draw the interval notation. So our 0, and then where there is x, so our first x is equals to 5. So if we have negative 1, negative 2, negative 3, negative 4, negative 5 there, and then we have 1, 2, 3, 4, 5 there. Then our first x is equals to 5. So we need to get the values which are within the two intervals here, x negative 5, x negative 5. So this is x equals to negative 5 and x equals to 5. So we need to look at the values which can fall within this region, the values which can fall within this region between x negative 5 and this, and the values which can fall within this region. Once we take this one back to this equation here, we want to see whether when we have the value here, let's say of negative 6, is it satisfying? Is it greater than 0? When we have the value within this region as 0, x to be 0, is it greater than 0? And then if we have the value after x here, which is let's say 6, is it satisfying x? Is this satisfying to be greater than 0? So what you do, you take any value before x equals to 5, negative 5, and then we put it here. So we can say we take x to be equals to negative 6. Okay. So if we take x to be equals to negative 6, so it would be 4 all over negative 6. And then we do what? We square minus 25. Is it greater than 0? So you look at that. Is that one greater than 0? We can take any value within this region, which we can take the value of 0 here to be x. So it's 4 all over 0 square minus 25. Is this one greater than 0? And then we also take another value here, either 6. So we can take 4 all over 6 square minus 25. Is it greater than 0? Okay? Are we together? So you need to check whether within this region, is it greater than 0? Within this region, is it greater than 0? Within this region, is it greater than 0? Okay, let's start from this first one. So minus 6 square is what? 36. 36 minus 25. So 4 over what? 11. Is this one greater than 0? Yes. So this is greater than 0. Now, if we put here 0, so 4 all over what? Negative what? 25. Is this one greater than 0? No. So this is not greater than. And then this 4 all over this and that. So 6 square is 36. So is 4 all over 11 greater than 0? Yes. So it is greater than 0. Now, if we put x here to be minus 5. So if we put x here to be minus 5, then it will be 4 over what? 4 over 0. 4 over 0, is that defined? So it is not defined. So that means we are not including x equals to minus what? 5. And then when we put x to be 5 there, then it becomes what? 0. So is it greater than 0? So it is undefined, right? So we are not including this figure. So how should we write the interval notation there? So our interval notation will now be from infinity, right? From negative infinity to which region? Negative 5. Are we including negative 5? So we are not including negative 5. The union of what? Are we including this 5? So we are not including 5. And then to what? To infinity. Are we together up to that? So we are not including negative 5 and we are not including 5. So when we are not including, we use the what? That's parentheses. Any question after that? Okay, let's do another example. If we are given to solve also 2 all over 6x squared minus 13x plus 6 less or equals to 0. Now, looking at this also, this one is what? Greater than, right? So that means this one is what?
4.
So if it is odd, then you should get something like that. If it is odd, then you should get something. Now, if you look at this example, this one is what? This should be what? And so this one should be and. Now, again, we do the same thing for this. So we need to equate this one, the denominator, to be equals to 0. So we have 6x squared minus 13x plus 6 to be equals to 0. And then we solve the values of x. So is that a perfect square? So it's not a perfect square. So we look for the two numbers, in which the product is 36. So we use the ASC method. So we look for the two numbers, the product equals to 36, and the sum equals to negative 13. So what are the two numbers? We have 9 and what? Is it 9 and 4? 9 and 4, right? And which one is negative? Which one is negative? Both of them, right? So we have 6x squared minus 9x minus 4x plus 6 equals to 0. So we factor out here 3x. We have 2x minus what? 3 minus 2. 2x minus 3 equals to 0. Okay. So since this one is minus, so the inside one should be minus. And again, we factor out the greatest common factor here, which is 2x minus 3. What remains is 3x minus 2 to be equals to what? So using the zero product property, so our x equals to 3 over 2, or our x equals to 2 over 2 over 3. 3 over 2. Any question after that? So those are now the intervals that we need to put them in the number. So we have our 3 over 2. So both of them are after what? X value. So we can put here 1, and let's say here 2. So 3 over 2 is where? 1 point what? 1.5, right? So it should be somewhere here. So this is our region, one of our region. And then 2 over 3 is between 1, right? So let's say there is our x equals to 2 over 3, and this one is x equals to 3 over 2. 3 over 2. Okay. Now, so we need to test this one now. So if we put here this region, after this region, we can put x to be what? 0. So we can say x is equal to 0. So 2 all over 6 multiplied by 0 minus 13 multiplied by 0 plus 6. Is this less or equals to 0? So we need to look at that. When we put here to be 1, so when we put x to be 1, so 2 all over 6 multiplied by 1 square minus 13 multiplied by 1 plus 6. Is this less or equals to 0? And when you put here 2, so 2 all over 6, 2 square minus 13 multiplied by 2 plus 6. Is this less or equals to 0? So you need to check those. Now, the first one will be what? 2 over what? 6, right? Is that less or equals to 0? So it is not. So this region is not satisfied. Now, when we put here x to be 1, so it will be 2 all over what?
-1.
So this is 6. So this is 2 all over 6 minus 13 plus 6. Is this less or equals to 0? So 6 is 12 minus 13 is what? -1. So it is negative. Is that less or equals to 0? So definitely it's less than 0, right? So that region is satisfied. How about the last one here? So this is 4. So this is 24, and this is 6. So 24 plus 6, of course, that one is positive, right? So is it less or equals to 0? No. So this region again is not satisfied. Now, what we put here to be 2 over 3. Now, when we put it back, there has to be 2 over 3. So one of the regions will be what? So when we put it to be 2 all over 3, then. So what happens? So when we put that one to be 2 all over 3, what does it happen? So what happens? So when we put here 2 over 3, here, let's say even here 2 over 3. So you get 6 multiplied by 2 over 3, you get what? 4, right? And then 13 multiplied by 2 over 3, you get something there. Or since we have factorized this one to be, so it will be 2 all over 6x, not even 6x, because we have factorized this form. Then it will be 2 all over 2x minus 3, 3x minus 2, And we need to check whether this is equals less or equals to 0, right? We have factorized that below 1, right? So if we put here to be x2/3, if we put here to be, let's say 2/3 here, 2/3 here, we get 0 here, right? Right? Are we seeing this? So when we bring this 2/3 to this region, so it will be 3 multiplied by 2/3, which will get what? 2. 2 minus 2 is what? 0. So if this is 0, then this becomes what? 0, right? So it will now be 2/0. Is it defined? No. So are we going to include this region? No. So we are not going to include that. Now, if we put here 3/2, if we bring 3/2 here, so it will be 2 multiplied by 3/2, which will get what? 3 minus 3, right? Which is 0 here. So the whole of this will be 0, right? So is it 2/0 defined? So we are not going to include this. So therefore, it is within this region, but it is not including 2/3 and what? 3/2. What is the interval notation? So it will be parentheses 2/3, 3/2. Are we together? Any question up to that? Okay, so if you look at this, this is now what? This is less than. So therefore, it is what? End. So you only find one. So it should be satisfying both the qualities. Any question after that? Okay, another example. If we're also told to solve x plus 8 all over x plus 3 greater than 0, greater than 0.
Leave it down a little bit. We can-
Greater than 0. Now, so to get the intervals on the Cartesian plane, then what you do is you can start by equating the denominator to be equals to 0. So you can let's x plus 3 to be equals to 0. Now, since x appears in both, then you can also let x plus 8 all over x plus 3 to be equals to 0. Since x is appearing in both of that inequality. So you get the values of x. So in this case, our x is equals to 1 minus 3. Now, what will be our x here? So you multiply both sides by what? X plus 3. So when you multiply both sides by x plus 3, what remains is what? X plus 8 equals to what? Equals to 0, right? Right? So when you multiply this by x plus 3 and this one by x plus 3, then you get 0 here. So what remains here, since this one will cancel, then it will be x plus 8 equals to 0. So our x will now be equals to negative 8. So our x is equals to negative 8. Are we together? Now, once we get those values, so therefore, those are our intervals in our Cartesian plane. So we have 1, 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, maybe negative 9. Okay, so we have negative 3, so it is that region there. And then we have negative 8. So now, since this one is greater than, Then, without even solving this thing, you can actually get the interval notation so easily. So what you do, you only test.
It's middle one, right?
Yeah, so if you know that this one is greater, then this should be what? Odd. So what you only need to do is to test this and this. If you want to solve it so far. That's the region and this one. If it is satisfying, this one. Else you can do follow. So you can start by letting. So you can start from this region. So if you let x to be equals to -9, will it satisfy this inequality? So we have -9 plus 8 all over -9 plus 3. Is it greater than 0? Another region here, we can put anything here. So we can let x to be equals to what? Let's say -6. -6. So -6 plus 8 all over -6 plus 3. Is it greater than 0? And then the last region here, we can put it what? To be 0. Anything there. We let x to be equals to 0. So we have our 0 plus 8 all over 0 plus 3. Is this greater than 0? Okay. Now, -9 plus 8 is minus, of course, right? -1. All over -9 plus 3 is -6. That minus and that, is it greater than 0? Yes, right? So that's what is greater than 0. When we put here minus, so -8 plus 8 is what? -6 plus 8, sorry, is what? Is 2. All over -6 plus 3 is what? Negative. Is this greater than 0? No. So that is not greater than 0. We come here, 0 and that's 0. You get what? 8 over 3. Is this greater than 0? Yes. So this region is not satisfying. This region is satisfying. That region is satisfying. Now you need to test -8 and what? -3, whether they will satisfy greater than 0. Now let's start from -8. So -8 plus 8 is what? 0. 0 all over a number is what? 0. Right? 0 all over 0 is always 0. So 0, is it greater than 0? Is it greater than 0? Is 0 greater than 0?
No.
So it is not included. Now, when we put the 3, now 3 -3 plus 8, we have a number there, but the below one is -3 plus 3 is 0. So that is not defined. So therefore, what is our interval notation? So it should be -infinity. Are we including -8? No. Union -3. Are we including -3? No. It's our interval notation. So you see now, you see how simple it is. So once you get your intervals there, then you only, if it is odd, so you just come and test for what? Those results. And then you use the union. You use the union. Any question? Any question after that? Okay, so since the other ones are similar, then have a quiz here for you, so we can do it in class. We can discuss. I don't this is 5, but it's I think 6 or 7, 8. Thank you. You can do it in a group of 3 or 2 or 1. So we have like 20 some 30 minutes, so 15 minutes. So you can discuss with your friend. Okay, so guys, online, here is a quiz. What's that?
Yeah, because
What's that?
Do we combine these options?
Oh, the first one and the second one? Oh, so for the first one, so you need to get, so you need to remove first of all the denominators. So once you remove the denominator, so you bring this value this here. So you make this one equal to 0. So apply the section that we did. Where we use the LCM to remove the what?
Okay.
So for the first one, what you can do is, so for the first one is,
Needs to decide that right square.
yep, so 1/2 plus 12/5 squared. So you bring this 5 all over x to this side. So minus 5/x. And this one should be greater than what? 0. So I did not tell you this. So you make sure the other side is 0. Make sure the other side. So once you go like this, then now you can combine. So what is the LCM? This common factor is what? 2 what? 2x squared. Right? It's 2x squared, right? So our least common factor here is 2x squared. So 2x squared divided by 2 is what? Is what? X squared. X squared. Plus 2x squared by x squared is what? Is 2. 2 multiplied by 12 is what? Minus 2x squared by x is what? Is what?
2x,
2x. 2x multiplied by 5 is what?
10x.
Minus 10. It's greater than 0. So you've already formulated that. Now, so since these are 2 values, so what you need to do first is you let 2x squared to be equal to 0 and x squared plus 24 minus 10x all over 2x squared to be equals to what? So you need to get the two intervals there. So here, our x is equals to 0, right? Our x is equals to 0 since you divide this one by 0. And then since when you multiply this one by x, 2x squared, you still remain with x squared plus 24 minus 10x equals to 0. Equals to.
I'm just confused why everything's divided by 2x squared.
Yeah.
So that is the least common factor.
Yeah, but I multiply.
So we want to add the 3 of them. So if you want to add, let's say you want to add 1 over 2 plus 1 over 4. Or 1 over 3 plus, let's say you want to add 1 over 3 plus 1 over 4. What do you do? 1 over 3 plus 1 over 4 is what? Yes, so you get the least common factor. And our least common factor in the denominator is what? Is what? Is 12, right? So it is equals to, so this is equals to 12 here. So 12 divided by 3 is 4. So 4 plus 12 divided by 4 is 3. And this one is equals to 7 over. So that is equals to 7. So it is similar to this. So what is our least common factor? And our least common factor is 2x squared. Right? So 2x squared can divide 2x squared can divide x squared. 2x squared can divide x. Right?
Right. Just the first time I'm learning it this way.
Yeah, so it is just similar to this. So you get the least common factor among the two. So how do you get the least common factor? Now, let's say you want to remove this denominator, like what you are doing. Let's say you want to remove this denominator. So what can you do to remove this denominator? You multiply by what? 2x squared, right?
And so then that's what you.
And that one, 2x squared is our what? Our least common. Yes, that is our least common multiple. Yes. So you actually divide. So you actually say now since this is our least common factor, then like what I just did is our least common factor is what? 12 is 12. So I just put here 12. And then now 12 divided by 3 is what? 4, right? 4 multiplied by 1 is 12 divided by 4 is what? 3. 3 multiplied by 1 is?
Just so I can wrap my brain around. Can I multiply both sides by 2x squared? And then whatever I get from that, then I can put that over 2x squared. That's what I'm essentially doing.
No.
You said multiply both sides.
Yeah, you can do like that, but what you want to do is we are trying to get those intervals, like just what we did. So we are trying to get those intervals whereby we can now test whether this is greater than 0 so that you can put them in the interval notation. You get my point? So yeah, you can do that as long as you divide this one. So you can just say this by this, you get what? So when you multiply this and this, you get what? X squared, right? When you say this and this, you get what? 2, right? Since this x squared will cancel. You get 2. 2 multiplied by 12. This by all of this is what? X and that one x will cancel. You get what? 2x. 2x multiplied by 5, you get what? Okay, is what? 10. So this is what you get. Now, this is greater than 0. So that's greater than 0. Are we together?
I guess we kind of have to be, right?
Yeah, so you can go and refresh yourself on
Well, I mean, just
how to add fractions.
right, but everywhere else, we've been just multiplying both sides by 10. If
Now
that's-
you can also go and check how do you add the fraction?
Yeah.
How do you usually add the fractions? So what do you do when you want to add the fractions? So you get the least common multiple on the one. On the denominator. Okay. So least common multiple. on the denominator. Are we together up to here? So now you equate this one to 0. Or since you have two of these, so you equate this one to 0. Now since you have x in both sides, then you can also equate this one to 0. Now since this one, you can multiply this by 2x squared, then it can still be equal to 0, right? So what remains is x squared plus 24 minus 10x equals to 0. Now, forgetting about that, now we have 2x squared, we have x squared minus 10x plus 24 equals to 0, right? So this becomes the quadratic equation, okay? Now, once it becomes that, then how do you solve this?
Using AC method.
AC method. So,
Yeah.
so you use the AC method. So the product is 24 and the sum is minus 10. What are the two numbers? Negative 6 and negative 4. So negative 6 and negative 4. So negative 6 and negative 4. So you now bring it here. So x squared minus 6x minus 4x minus 10 minus 20 plus 24 equals to 0. So x minus 6 minus 4 x minus 6 equals to 0. So using the product, so you get x minus 4 x minus 6 equals to 0. Using the zero product property, so you get x equals to 4 and x equals to 6. X equals to 4 and x equals to 6. Now, since we had our x to be 0, our x equals to 4 and x equals to 6. So we take our 0. Since x is between, since 4 is between this and this, then we can take the last one there, which is x equals to what? 6. And then we test it. And then we test. So x is between 0 and 6. X equals to 4 is between 0 and 6. So we can actually use the two regions, 0 and 1 and 6. Now, when x is in the other side, so we have our equation here. So we have our equation x squared minus 10x.
Isn't it positive 4 though? Yeah, so I see. Sorry, go ahead. Just go.
So this is x equals to 4, right?
Yeah.
And this one is x equals to 6, right?
Yeah.
So, and then we had another one, x equals to 0 for this, right? Right? So we said we equate this one to 0. We also equate all of it to 0. So we had x equals to 0. And then we also have x equals to 6 and x equals to 4, right? So now since x is between 0 and 6, x equals to 4 is between 0 and 6. So we don't have to test the one for 4. We only test the ends, the two ends, which are 0 and what? 6 and 6. To see whether it will satisfy that region. Okay. So you can actually test x equals to 4 here. So, but now you need to test whether it is within 0 and 6. Okay. So now, so this is our equation here. So when we let x after 0 here, before 0, I mean, then we have -1, right? So we can let x to be equals to -1. Then is this, when we put here, is it greater than 0? Are you okay?
Yeah, just go ahead. Yeah, you're fine.
So if we let x to be equals to -1, is it greater than 0? Then if we let x to be equals to 4, you can test x to be equals to 4. Is this greater than 0? If we let x to be equals to, after 6 is, let's say 7, is it greater than 0? So let's try x equals to -1. So when you put -1 here, what do you get? You get 1, right? When you put -1 here, you get plus, right? So plus 10, and then plus 24. All over 1 square is what? 1. So 1. Is this greater than 0? It will be greater than 0, right? So this is greater than 0. When we slot in x equals to 4, you need to test whether it is greater than 0. So when you put 4 here, and then you need to check whether it is greater than 0. Now, since this one is greater than, then this should be what? Oh, so go and see whether this is giving you the O. So it should be this. Okay, so you go try that, and then you can send it through Google, or you can bring it to class on Wednesday.